Okay, so this is basically a challenge video, experimental challenge to both flat earthers and globe earthers, involving the moon. But first I'm going to explain the basics of the globe model again, just in case people don't remember what it is. So, I have the Earth pointing towards the sun, which is over there, and it is tilted back the way it would be during the winter solstice. And we know that during the winter, you can see the shadow of an observer. This is at about 40 degrees latitude in the northern hemisphere. Shadow is pointing upwards, right, towards the northwest, which means that the sun is coming from the southeast. That's at sunrise. At sunset, if you watch the shadow, you'll see that the shadow is pointing up towards the northeast, right? Which means that the sun is coming from the southwest. Which means during the winter solstice, or in the winter in general, the sun rises in the southeast and sets in the southwest. And now we have the opposite. The Earth is tilted towards the sun during the summer solstice in the northern hemisphere. You can watch that shadow there, see that the shadow is pointing down towards the southwest, which means that the sun is coming from the northeast. It's the zenith, and then you can now see the shadow is pointing downward at the southeast, which means that the sun is coming from the northwest. So, the sun rises in the northeast and sets in the northwest during the summer solstice. Now we have the equinox. So, of course, we're not going to do both equinoxes because they're both the same. The Earth is neither tilted towards nor away from the sun, and so see as the shadow just begins, it's pointing directly towards the west for the most part, and therefore the sun rises in the east. Okay, so now for the fun part. So I created this little table, so to speak, to detail what we should expect the moon to do at different times of the year. So, this is winter half moon, so the part that's not shaded is the bright part of the moon. So that means the right side of the moon is lit up. It will act like an equinox in the winter. So in other words, on the winter solstice, the Earth is tilted away from the sun, right? And if we take the moon, where is the moon? The moon has its right side shaded. But look what it's doing. The moon is essentially, I don't know if I'm getting this angle very well. The moon, it's in half moon right now, and it's essentially pointing towards the Earth as if it's an equinox. So basically, if I just rotated this, because the moon was on this side, if I just rotate this, the moon is essentially doing that. Right? So you can probably tell that I don't put much thought into these videos, or planning, but whatever. Anyway, I decided to show that again in case it wasn't clear. The left side of the moon is lit up, and look at what the moon's doing. It's basically shining its light on the Earth. You can see the Earth is tilted neither towards nor away from the moon. So the moon is literally acting like the sun during the equinox. So during the winter solstice, during a half moon, any half moon actually, whether it's left side lit or right side lit, it will act like a solar equinox. Now it's going to be slightly off because the moon's orbit around the Earth is actually slightly off the ecliptic, I think about 5 degrees, but we should still expect it to rise mostly somewhere between maybe 85 and 95 degrees and set around the same place. Now, as you can see, I've written here, the full moon during the winter solstice will act like a summer solstice. This one is very obvious. The moon's not lit up right now because the scale is obviously not correct. Nevertheless, if the moon is here, it will be shining on the Earth as if it is a summer sun, right? Because the Earth is tilted away from the sun, which means the Earth is tilted towards the moon during a full moon, because the moon is on the opposite side of the sun. So we would expect the full moon to rise in the northeast and set in the northwest, in the northern hemisphere. Okay, I'm going to race through the rest of these because I think the pattern is pretty obvious by now. So, this is during the spring or fall equinox. The Earth is tilted to the side, which means neither towards nor away from the sun, but the moon, during a half moon, the Earth will be tilted away from it, right? As you can see, the Earth is tilted away from this half moon, which means left side lit half moon will act like a winter solstice sun. So we should see it rising south of east in the morning, or whenever it rises, and it should set to the south of west. And obviously, if the moon's on the other side of the Earth, so if I took it and put it over here, it would be a half moon with the right side lit, I believe, and that would act like a summer sun. Okay, and finally, the full moon during an equinox will act like an equinox, right? Because if the Earth is tilted neither towards the sun nor the moon, obviously because the moon's on the other side, that means the moon will act like an equinox and rise in the east and set in the west, just like the sun does during the equinox. And that's pretty much what's detailed here. During the winter solstice, the half moon will act like an equinox. During the winter solstice, the full moon will act like a summer solstice. And during the spring or fall equinox, the half moon will act like a solstice. I erased the summer winter because it actually depends on which moon you're talking about. And the full moon will act like an equinox, just like the sun is acting like an equinox. And the summer is just reversed from winter. So that's basically my challenge. I want flat earthers and globe earthers, and I may join in myself, to basically make observations of the moon on the solstices, or even off the solstice as well, or off the equinox. You can just model it out. Where is the moon relative to the sun? And you can see whether it actually follows the path that we would expect on the globe model to prove or disprove it.